All right, welcome back. We are moving on to 10.5, and we're going to be looking at the parabola. And you might think, well, I thought we look at it in pre-calc 11. Yes, you did. We will look at the parabola from a different kind of perspective, I suppose. So a little different, but very, very much the same. Okay. All right, so here we go. Here is the cone. Okay, so again, we're going to figure out how we can get a parabola from the cone and the plane. And here's the plane that is intersecting with this cone at the same angle as this generator. Okay, so that means the plane and the generator are actually parallel. Okay, if they're parallel, then we actually get this shape of a parabola. Okay, now parabola can be also be drawn using the focus, just like what we seen in what is it, ellipse and hyperbola, except this time we actually get this one extra line here, right here. Okay, now here's the focus, and there's the vertex. Well, I'll show you the definition here. To draw this parabola, the point on the parabola are actually a set of points that are equal distant from the focus and the line. Okay, so well, what exactly does that mean? Okay, so I'll show you what that means. So again, the point on the parabola, so let me just pick a random point. Let's say this point right here. Here's my P1. So we have a distance between this point and the focus, and then we also have this distance between the point and the line, and these two lengths are supposed to be the same. Okay, obviously from my diagram they don't look the same because my parabola and the line are not drawn in the right position. Okay, so that's why, but in theory they should be the same distance. Okay, so I can show you another point, maybe somewhere here. Let's say there's my P2. So again, this distance, D2, should be the same as this distance right here. Again, the distance between the point on the parabola to the focus should be the same as the distance between the point on the parabola and this straight line. Okay, so that's what it means. And the collection of all those points actually forms the shape of a parabola. Okay, so that's what it is. Here is our example. I'm sure you've seen this before in pre-calc 11. Again, there is the equation in standard form. Y equals 2 times x minus 1 squared plus 2. I know it's not exactly in this form, but we can move the q to the left quite easily, right, by moving by minus 2. But anyways, we've seen this form, the vertex form, quite a lot, right? So we know how to graph this. The vertex is 1, 2. That is right here. We know this is a parabola that opens upwards. Direction is up because the value of a is positive. Therefore, the domain is going to be all real numbers, and the range is going to be greater than equal to 2. Okay, because it opens up, and the vertex would be the minimum. The equation of axis of symmetry, well, it's going to be a vertical line. Remember, parabola is a mirror image. Okay, so equation of axis of symmetry is going to be at x equals 1. Now we need more points. We can simply plug in the number 2 into x, and the reason why we plug in 2 is because, well, because our vertex is at 1, so you just need to find a couple points around your vertex. So in this case, we should get 4. So 2, 4, and again, because it's a mirror image, once we get this point, we should be able to get that point as well. You can get another point by plugging 3 into x, but I believe that would actually be outside of the grid that I provided here. But I believe this is 10, so I will just forget about it. And there's my parabola. Okay, so again, this is our old friend, regular kind of parabola that we dealt with. This one opens up because the value of a is positive. It would open down if the value of a is negative. Okay. However, we did this in math or earlier in the chapter or earlier in the year in the transformation unit, I believe. We can actually reflect the graph in the line y equal to x by switch the x and y in the equation. And therefore, we get this, x minus p then equals to a times y minus q squared. And if a is bigger than 0, okay, so let's say this case, okay, let's not worry about this. This case, the one we have here, this case, a is bigger than 0. And recall, if we reflect over y equal to x, it actually gives us this graph right here. Looks something like that. Okay, looks something like that. So if the value of it was positive, if you reflect over y equal to x line, it opens to the right. As you can see here, if a is bigger than 0, then the parabola opens to the right, and the vertex would be at p comma q. Similarly, if a is less than 0, that means originally it opens downward, and if we reflect over y equal to x, then it results in a parabola opening to the left with the vertex p comma q. Okay, so again, we've done this before in transformation. Okay, so now we're going to be looking at the general form of a parabola. So there is, again, our old friend. If it says if a equal to 0, that means this is gone, then we only have y squared term, so then it looks like that. That means the parabola opens sideways. Okay, again, if a is 0, that means we do not have the x squared term. That means the parabola opens sideways. If b equal to 0, that means we don't have the by squared here. That means we just have the x squared. That's our old friend in predicate 11. That means the parabola opens up or down. Okay. All right, so let's look at this example here. We have the graph 0.5 y squared plus x minus 2y plus 5 equals 0. You can see that there is no x squared term. That means this parabola is going to open sideways, okay? So we need to write it in this form, this standard form, okay? That's the standard form. So then that means I'm going to isolate the x on the left-hand side. So I'll keep the plus 5 there. And I'm going to move the y squared to the right. And the y also to the right. Okay, so that's my first step. I keep the x and the constant on the left and move all the y's to the right so then I can complete the square. Okay, so I'm going to factor 0.5 out. It's going to be minus 4y divided by 2 squared is plus 4 minus 4. So then we end up with negative 0.5 y minus 2 squared. Negative 0.5 times negative 4 is plus 2. And then move that to the left, we get x plus 3 equals negative 0.5 y minus 2 squared. So we have our center, or vertex, is going to be at negative 3 comma 2. Negative 3 comma 2 right here. Okay, and we know this parabola opened sideways. Now the value of a, you can see, is negative, therefore we know this graph is going to open to the left. Okay, open to the left. So I guess we can then find the domain, because opens to the left, we know then x has to be less than or equal to negative 3, and range is going to be all real numbers. Okay, good. What else do I need to find? Direction of opening. Direction of opening is going to be left, and equation of the axis of symmetry, AOS, is going to be y equals 2. Okay. All right, because that's where our vertex is, and it's opening sideways, so we know the mirror is right here. That's our mirror. Okay, now again, we need more points. We can then simply plug in some values. Well, I know it's going to open to the left, so it makes no sense to plug in negative 2 into x. So what we should do is we should plug in negative 4 into x. Okay, put negative 4 into x. So then where is it? Where's our equation? Okay, so from here, I'm going to put negative 4 into x. Negative 0.5 y minus 2 squared. Okay, so that's negative 1, and we know, okay, fine, I'll do step by step. Okay, and then we divide both sides by negative 0.5, we end up with a 2. And then we get y minus 2 squared. I guess I can then square root both sides. Then I get plus minus 2 root 2, y minus 2. And then get 2 plus minus root 2 equals y. Okay, now this is not very nice. This is not very nice. Okay, so what we can do is instead, okay, fine. I guess we can do a little cheat We'll cheat a little bit, I guess. Okay, so because the value of a is 0.5 or negative, well, I guess negative 0.5, but the actual value without the sign, the absolute value of a is 0.5. That means if I go 1 up, I'm going to go 0.5 left. And then 1 down, 0.5 left. Okay, I'm sure you probably know this too anyways. And if we go 2 up, it's going to go 4, or sorry, 2 to the right. 2 to the left, okay? And 2 down, 2 to the left. Okay? If we go 3 up, it's going to be 4.5, which is not a nice number, so I'm not going to do it. Okay, so there is our graph. Okay, so there you go. It might be easier, I suppose, if we let y equal to some value and solve for x. I don't know. That probably would be better, I suppose. Yeah, instead of what I did. Okay. So yeah, maybe we'll do it that way. So we'll try one more time. See if we get a better luck this time. Even though we have the equation already. Oh, plus 3, sorry. So you can let y equal to 3 and then solve for x. I think that might be easier. Okay, let's see what happens. So if you let y equal to 3, then this becomes 3 minus 2 squared. So then you get x plus 3 is equal to, well, 3 minus 2 is 1. 1 squared is 1. Negative 0.5. Then you can move the 3 to the right. Then you get x equals negative 3.5. That's exactly what I said there. Okay. So maybe that might be easier actually, and then you just need to make sure you get some nice points like that one right here, so you can get your shape, the parabola shape. Okay, so there's the last practice question for you to do. Okay, so we're doing the opposite actually. Okay, so given the graph here, what is the equation of this graph in standard form? I'll give you a few minutes. Okay, good luck. Okay, so this parabola opens sideways. So we know it's going to be in this form. A y minus q squared. Okay, because it opens sideways. If it opens up or down, then remember we can use this. Okay, so it really depends on which graph, what kind of graph we have. Then we need to use a different standard form, right? This one for sideways, and this one's for up or down. Okay. Now we have the vertex of negative 1 comma 2. So we know right away it's going to be x plus 1 equals a times y minus 2 squared. Okay, because that's where our vertex is. We can then solve for a using another point that's given to us. So x is 1, so 1 plus 1 equals a times y is 3 minus 2 squared. We get 2 equals a times 1. Therefore, a equals 2. Therefore, our equation is going to be x plus 1 equals 2 times y minus 2 squared. And there is your equation. Okay, that is it. I hope you understand this, and I hope you're excited because we are done. At least I'm done. You might have other, I don't know, tests or whatever. I don't know. And anyways, I'm done. So, and there's your practice questions to do. Let me know if you need some help. Good luck. See you. Bye.